Welcome back, and we're now going into our final session of our HPC Roadshow. And for the last time today, remember, if you have something you'd like to ask our presenters, please click on the question mark icon on the Teams app and type it in. Time permitting, we'll answer as many of these questions as we can during the event. We have a special opportunity for our attendees. A secret password will be given out during each session. Just like you see above, make sure that you take note of each one. The session for this password is EDGE. Attendees who provide at least 7 passwords by the official close of our event can unlock training given by the Boston Trading Academy this Friday, the 2nd of October. On Thursday afternoon, a form will go live on the same page you registered on. We'll also provide it to you over email for you to input your codes. So without further ado, I'd like to introduce Talyor Deacon and his team, who head up the Boston Enterprise Solution Group. They'll be talking about the impact of AI on business and society.
Thanks, Chris. Appreciate the introduction, and really excited to share on today's session. Let me just see if I can share my screen here. Okay. Fantastic. Well, welcome everybody to today's session on how AI is impacting both business and society, brought to you by Enterprise Solutions Group here within Boston. And I'm excited to be joined today by two guests from a very good partner of ours, Faktion, Niels van Weereld, VP Business Development, and Vladimir Dzyuba, who's Senior Machine Learning Engineer at Faktion. And they will be sharing with us quite a lot of in-depth case studies and use cases for the projects that they've worked on over the years. And really excited to kind of talk through them. It's going to be quite an interactive session today, and also joining us from the Boston ESG team is Senior Technologist Andrew Addison as well. So he's going to be joining into the commentary as we kind of go through this. But I think AI. It's no secret that AI represents a huge opportunity, one of the biggest opportunities I think we'll see in our lifetime, for both society and business to take advantage of its capabilities and possibilities. And today's session is really all about exploring what are those possibilities, what is the capabilities of AI, how is it going to impact our lives both at work and potentially at home. And I think, during the current times, with COVID-19, it's very real to all of us how technology has come to the forefront, and having to respond not only to deal with the actual virus, but also how we as kind of citizens and fellow human beings are able to respond in our own way, leveraging the power of technology to adapt in strange times like these. Faktion and Boston have been working together for quite some time now, and we've developed a really solid, great relationship, working on various different projects together with various different customers, and it's a hugely complementary relationship. Their skill sets and experience is very deep, broad in various aspects of AI and machine learning, which complements Enterprise Solutions Group's skill set very nicely. And we hope that they will continue to work with us, and we'll continue to grow this relationship going forward for many years to come. So without further ado, I'll introduce Niels now. He's going to share us a little bit of background around Faktion and where they've been, where they've come from, and we can take it from there. Niels?
Yes, great. Thanks, Taylor. So, hi everyone. My name is Niels indeed. Thanks for the introduction already on me, as well as my colleague Vladimir, who's sitting next to me. And he'll dive into the discussion a bit later, but let me first try to share the screen and take over the presentation here. I should be sharing it here. Should be coming up right now. I don't know if anyone can confirm that you can see the screen.
Not yet, I'm afraid.
Let me try again.
Yeah, not quite.
Should be better now. Okay.
Yep. There we go.
Yeah.
Good.
There we go.
Good to go. It's always exciting. So maybe as a short introduction to begin with, who is Faktion and where do we come from indeed? So Faktion, we're a Belgium-based AI engineering company. We call ourselves an end-to-end AI solution provider, which means that in essence, and it's also where we come from and where we started, is that we are a technical company, an engineering company, and we basically build AI and machine learning, whatever that might be, and we'll go into more detail afterwards. But we build AI and machine learning embedded solutions and products for a whole range of customers and industries and problem statements where we think AI or machine learning could add value and could solve specific business cases. We have also recently, so end of last year, we've established an office in Singapore for the Southeast Asian market. So you could argue, you could say that we are quite fast growing and quite ambitious. We've also won the AI Scale Up of the year 2019 in Brussels, so last year, and our CTO, which is also one of the founders, won the European CTO of the year 2019 award as well last year. So that's something that we value highly, is the skills and the experience, the expertise that we have in-house. That's what makes us such a big success, I would say, what makes our journey so far a big success. When I say AI, so there's a lot of confusion about what is AI, what is machine learning, etc. When we say AI, or as Faktion, when we say AI, we basically mean machine learning. And the easiest example that I always use, so someone who might have already seen a keynote of mine can probably relate to what I've said earlier, but what I always use is the example of a spam filter. Traditionally, if you used to build a spam filter in the past through traditional methods, which is also called AI, because AI basically is just a way of making a computer or a machine, do or mimic intelligent and human behavior. So the way we used to program a spam filter, also AI, was quite rigid by hard coding every single opportunity or every single possibility how someone could try to send you a spam email. For example, if the email subject contains Viagra, then it is probably spam. If the email body contains that some prince somewhere wants to give you $1 million for free, then it's probably also, unfortunately, it's spam. But you can imagine that if you want to develop a spam filter that is that has a general good performance and is able to intervene in all these different options and possibilities that one might have to build such a spam email, it doesn't generalize, it doesn't scale, and it's just not a scalable approach on doing so. How machine learning approaches would go about that is we would feed an algorithm with hundreds and hundreds of examples, good examples of emails that are not spam, and hundreds of examples of emails that are spam. And basically the algorithm will find out or will configure its own set of rules, its own set of parameters on which he determines whether a new email that will be tested is spam or not. There's a difference between a traditional expert system, which is also a form of AI, and machine learning, which is a newer, a younger form of AI, which is also what we mean when we say we build AI solutions. But that's just as a setting the scene, I would say. And in doing so we're a technical company, we build these type of solutions for our customers, but we also help them in finding the right use cases, because that is one of the most important parts where we see that still a lot of attention needs to go to, is helping customers, helping companies in finding the right use cases that could actually provide value for them. Because there are a lot of use cases out there. More than hundreds of use cases in business context have been developed over in the entire world, and for some companies Some use cases are valuable, for others they are not. And it's really the art or the trick is to find this use case that is relevant for your specific company. And that's what we do with our strategy offering as well. So we try to guide our customers from being a traditional company to what we call a data-driven and an AI-enabled company by just looking, scouting for those use cases that your company is ready for to develop, and also that will provide value and it will help your company achieve your company goals. Because that's, in the end, when we look at AI and machine learning, we don't want to innovate for the sake of innovation. We don't want to build an AI proof of concept or an AI solution just because it's good to have it in our corporate statement or annual statement and just to be looking into AI, just to be able to say we are working with AI. That's not the goal. AI or technology in general is the means to an end, and the end is achieving your corporate ambitions and your corporate strategy. And that's how we try to help our customers in before building it, also identifying which ones they are, which ones we should build, and then also monitor the progress and how they are actually helping according to plan on realization of ambitions and goals. So that's basically, in a nutshell, the overall offering, I would say, of how we try to help our customers. We've been founded in 2016, by the way, so we have been around for 4 years now. And maybe as a summary on the introduction, Talyor, before I hand it back to you, we are a company that has already spun off 2 separate companies. So we have developed 2 spin-off companies of Faktion. They're 2 product companies. Faktion, in essence, is a service company. If you would combine them all together, we would now be a team of about 80 people with a consolidated revenue of about 4 million and a bit in only 4 years, with 2 offices, one for Europe, one for Singapore. So I think we had quite an interesting ride already. Talyor, I think you're still on mute.
Yeah, you're muted, Taylor.
Thanks, guys. Always good to find the mute button. It's quite handy. Thanks again for the introduction and the background. It's very useful. Help our listeners today to understand a little bit about Faktion. So really, I guess before we launch into kind of our use cases, I think it's very clear that, you know, AI is a very broad subject, and to your point, you said, you know, we don't want to innovate for the sake of innovation, but it needs to have a measurable impact on its on its outcome or set goal or set objectives, shall we say. And really, kind of these next kind of few use cases and projects that we're going to kind of go through really kind of outline some of the possibilities in the various different scenarios, whether it's more society based or whether it's more business based, that AI has, right? And to your point, we are talking specifically more about machine learning and developing machine learning algorithms. So I think, you know, it's gonna be valuable, you know, at the end when we're going to open things up for, you know, questions for people to kind of come back to potentially one or more of these use cases to kind of talk around how, you know, how were the objectives defined, you know, how was the impact kind of measured, right? And then how, you know, and AI is definitely more of a journey than a destination. So we want to kind of potentially keep this, you know, open to kind of revisiting some of these different use cases. But I think the next one we have up here is kind of a use case around automated email processing. I believe that's the kind of next slide we can go to. Do you want to walk us through that?
Yeah, definitely. And indeed, maybe to already jump a bit ahead on conclusion, if you want to define what is the goal or what should be the outcome of a proof of concept or a solution that you want to build, it can be either something that you can measure, like hard measurements, hard KPIs. What do we want to save? How many time do we want to save? How many FTEs maybe do we want to save in a specific process? But it could also be something that is more intangible. For example, employee satisfaction or customer experience is also one of the key benefits that is often related to AI or machine learning projects that we do. And this one is a good example of that. So we've done multiple similar projects, of course, but for one specific governmental body in in Belgium, we were looking into analyzing and automating the treatment of incoming complaint emails in order to prioritize which ones do we need to answer first and what actions do we need to take on corresponding to which complaint or to which message. The problem over there was that there was a team about 10 FTEs big that was handling all those incoming complaints, and that was basically just reading in a full-time reading a mailbox where messages are coming in. You need to look into them, you need to interpret them, you need to try to understand what the real message behind it was, and then you need, as a human, to prioritize them, start taking them up, and start taking actions in the back end. First thing is that, of course, you had a team of 10 FTEs, then again, you only had a team of 10 FTEs. And there were times that when something was not going as expected, for example, in the operations of this specific governmental body, that the number of complaints, the amount of complaints would increase, would peak, and then your 10 FTEs would not be able to cope with them in a way that you could be able to have a swift response towards the person that was sending you the email. So you had a capacity problem. On the other hand, you had the fact that it's basically just a boring task, just reading emails. And then, because these people, those 10 people, they weren't reading the emails themselves. So they're reading it, they're interpreting it. The easy ones, they could probably fix themselves by just sending a specific reply or say, okay, you can find your information here and here in a sort of self-service kind of way. But for the more challenging ones, the more complex one, they were just routing it, forwarding the email based on the contents to a department that should take it up. And you can imagine that it is boring, but it's also low value. You're just not adding value in that part of the process as a human. And people would suffer from bore outs. There was a high relation in the number of FTEs, new FTEs coming in, FTEs dropping out of the team because they were just having a bore out, or they wanted to do more challenging stuff, which also puts a lot of stress and a lot of pressure on the team, the management of the team, and the operational management of the department. So I think in this specific case, what we did is incoming emails were put through NLP algorithm, so natural language processing, which is a subdomain of AI, and we can go in some more technical details if you want. But basically what we try to do is we're going to translate this human language. That is the biggest challenge. Human language, natural language is unstructured. The way that we communicate with each other is unstructured. It's not binary like computers do the math or communicate to each other. We need to translate this unstructured language into something that is manageable for computers, so zeros and ones basically. And that is the field of NLP, where we are transforming sentences, words, emails, so a combination of sentences into a meaning that a computer can understand. And that's what we do of how we tackle this problem. We are transforming every word in a sentence into vectors that will enable computers to give a meaning, to give a class to a specific email. Okay, this is a complaint related to this specific topic, and this is a complaint related to that specific department or that specific topic. And based on that, we could automatically, instead of having a human read it and then pushing the forward button and entering an email address, etc., we could automatically route the email to the right department, for example, which is, of course, a time saving. There's no argument there. It's just a time saving. You don't need anyone anymore, not a person anymore, to read and interpret and forward the email, which would take about, I don't know, depending on the length of the email, would take about 5 to 10 minutes maybe, but you can do it in seconds. And on top of that, employee satisfaction and also customer experience, because you can imagine that the speed through which we can process these complaints increase significantly, they all benefit from these type of use cases. So I think this is a very valid, valuable one that is applicable for almost every company that has shared mailboxes or that has shared services centers that handle a lot of high volume of incoming, rather routine questions or queries.
Absolutely. So the impact was kind of could be measured in multiple ways. The impact on the actual whole holistic customer experience in terms of how fast people were being responded to, and then the impact on the actual employees and their well-being in terms of it's a menial, trivial task that there was a very real opportunity here to automate it and to streamline it and to make it take a very laborious, tedious task, right? And kind of bring that element of the kind of machine automation to it. And I'm very intrigued actually on the sentiment. So would actually be able to pick up actually more, if somebody was really angry in an email versus someone that was not, let's call it, not so angry or using very verbose language and so on.
Yeah, definitely, and I think Vladimir can maybe go in a bit more detail. But what we can definitely distinguish from each other is the two sides of the spectrum. I would say, like, is someone writing this email who is frustrated or angry? When someone is frustrated and angry, you will start using other types of vocabulary. You will start using other types of other ways to combine your sentences, to make up your sentences, than when someone is happy and everything is going well, etc. Yeah. And like these two different sentiments already basically, like, this is high priority because we think he's angry, or lower priority because everything is okay and going smoothly. This distinction is already quite valuable, and you could go even in a bit more detail if you would like in different sentiments, but already this black and white difference between angry or happy is an important one to take into account.
Absolutely, absolutely, and there's a lot of directions you could go into in terms of potentially moving into the predictive space around that customer, right? Mm-hmm. And their future potential interactions, with the company, which kind of leads us on to kind of the next use case we wanted to kind of go through, which was all around predictive maintenance, which has been talked about so much. Across the industry, because it's a huge problem, right? It's a huge problem across, automotive, right, and manufacturing industries, right, who are all very machine-based and developing parts. How do they look at clever ways and to apply machine learning and AI to predict kind of failure of their potential parts that are on, let's say, planes, for instance, and in this case, cars.
Yeah, indeed. And this one I find a particularly interesting one, because you would say we've done a predictive maintenance, maybe as an intro, a predictive maintenance project. We've built a platform for Bridgestone, so the tire manufacturing company. And you could ask a question like, what is Bridgestone's interest in predictive maintenance? Because they produce tires, right? So they don't have any other components. They don't build cars themselves, etc. But the big problem that they had, basically, they had two: upcoming competition from the Asian markets. So they were able to produce in lower costs, higher speeds, more efficiency in the Asian market. So this competition was getting more fierce, and it was more and more difficult for Bridgestone to compete. But also, and what is the biggest problem, the biggest concern, is that tires don't basically produce, I would say, loyalty for your customers. So Bridgestone had a huge loyalty issue when selling to end customers, to consumers, because at least for me, I don't even know which brand of tires is under my car. I just need tires, and if they're broken, I'm gonna need new tires, and I don't care which one is under there. And that's the biggest problem that they have. That's basically the biggest problem that they have, because how can you forecast your revenue? How can you make sure that you keep your sales up and that you keep increasing your sales if you don't even know which one will buy Bridgestone again once their tire is going flat or is broke or needs replacement? So that was one of their biggest challenges. And what they did is they developed a digital strategy and also more of a service strategy. So they wanted to go more towards a cars as a service model in the future. So what they did is they established the MySpeedy network, the digital garage MySpeedy network, and that's basically a network of mechanics and garages that are under the management of Bridgestone. So there they already went a bit further in the value chain, not only producing tires, but also providing maintenance services to consumers, to drivers of cars, owners of cars. That's the first step. And then as a second step, they wanted to build an app and a predictive maintenance platform for everyone who wants to tap into the platform. It's free to use. It's only rolled out in a few companies in Europe for the moment, but they will be rolling it out in other countries soon. And it's free to use. You can just basically subscribe to this type of platform or enroll, and then you get a dongle sent home that you can install in your car. You have an app for which you have access, and we will start gathering data from the car. And instead of basically running to failure, so on a cold Monday morning being stranded by the side of the road because your battery is dead, they wanted to predict these type of events up front, like 2, 3, 4 weeks in advance, so you could still schedule a meeting or schedule an appointment at the dealership, at the maintenance center, to get it replaced and not being stranded and losing time and being frustrated. So that's what we did. We've built the predictive algorithms, the intelligence behind the platform that is using the data coming out of the car to make predictions on battery, on brakes, on tires, of course, and on other types of components in your car to help you being prepared to be proactive, to maintain your car in a proactive way instead of being being frustrated by the side of the road. And a fun fact on that side as well, it actually spun off a separate venture for Bridgestone, because by building this or through building this this platform, we needed training data. So we needed to gather a lot of data on cars in different conditions. So what we did is, or at least not Faktion, but someone from the Bridgestone team, what they did is they had someone drive hundreds and hundreds of kilometers throughout Italy, throughout Rome, in different conditions, on different type of roads, etc., with potholes, without potholes, all these type of things, just to collect training data. But in the meantime, we were able to basically compile all this data into one map, a roadmap basically, an actual roadmap for the city of Rome with a quite accurate location of potholes and the condition of these type of the roads that the tests have been done on. So this is a new venture that's spun off from Bridgestone by building this project. They are now selling data that they gathered throughout the training phase to cities, because they have the data on the condition and I would say the roads that need maintenance or that need some kind of repair, which is of course highly valuable data for the city, because they want to keep their citizens happy by providing them good infrastructure. So it's a nice little side story there on a business that spun off from that.
Yeah, I might have to put a call into them to see if they can come to England and kind of help the help the councils and the government map out some of the potholes around this country, because we could definitely use that. And so basically they'll be able to fit the kind of the cars with sensors, and from those sensors it sounds like there's quite a lot of data points that they're able to then extract and pull out, and then take and then apply your machine learning algorithms to kind of interpret that data, and also create alerts based on various patterns that you're saying. Would that be an accurate reflection of what's happening underneath the hood?
Yeah, indeed. Maybe I'll chime in. So indeed, that's what's happening. So the algorithms, the machine learning algorithms, look at the whole set of data that's available, not only tire data, not only brakes data, and so on, but the whole set of data available about the cars, and try to make predictions, very fine-grained prediction as to what is going to happen within next day, next week, next month, and so on. And these kind of predictions can be used for like Neil said, scheduling visits to the garage and so on. And here, maybe I would like to highlight and go back a bit to the point that Niels made a bit about the spam filter example. So indeed, one of the main strengths of the AI-based approaches is that they can pay attention and they really can focus on very fine-grained pieces of contextual information, right? So for instance, the reason that Bridgestone was collecting pothole data is because we noticed, all the algorithms rather noticed that if a wheel has been to a pothole, is important in the wheel condition. Sorry, indeed, and so if we compare it with the rule of thumb that the mechanic might use by saying, okay, maybe if I look at your cars next week, this is really precise and this is really data-driven. It can also adjust to different contexts, right? For instance, the way the tire wears out in Italy in the warm climate, driving in the mountainous area, very different from the way it wears out in Belgium, rainy, where it always rains and quite flat, right? And so by leveraging the algorithm and really focus on very small details in the data, maybe temperature here is somewhere there, the amount. Here we can build very precise predictions.
Great, thanks, Vladimir. I think we're having a little sound issues. You're either really quiet or really loud. One of the two. If we could have only have predicted that today, that would have been fantastic, right? So I think that, again, coming back to kind of the theme of today is around the impact. So that's got it's got an amazing impact, right, on us as consumers. Right, and our quality of life, so to speak, when it comes to breakdowns and car maintenance and things like that, which we all dread, right? Being stranded on the side of the road. So, help, and we're all busy, right? We're all busy, and yes, we normally do ignore the kind of red flashing lights in the dashboard, until it doesn't start potentially. For some of us, I'm not speaking from personal experience, by the way. I'm definitely not. But I think areas like these, where wear and tear of vehicles, and being able to have that data, right, and be able to then apply these type of models to, again, have provide answers and potentially in real time to us as consumers, people driving the vehicles. It's huge. It's a real big impact to us as people driving these vehicles. So I think what we have next on the agenda here is really all around. We're kind of moving on to more of surveillance, kind of real-time camera surveillance monitoring, and how machine learning is kind of moving into that space, into that sector, which. In today's world, there's use cases I've heard about it in terms of helping us with the social distancing, right? Those are pretty permanent, pertinent use cases, especially inside hospitals, making sure people are keeping the right distance in kind of workplaces. But I think kind of the use case that we have kind of in front of us, is around compliance. Being able to assess that compliance potentially in real time for health and safety purposes, but for lots of other types of regulations. Do you want to tell us a little bit about how this project came about?
Yeah, definitely. So there's multiple flavors into these type of projects, that we've done several, but basically what it boils down to is that we use computer vision. So again, a set of algorithms to analyze and to interpret images or video, so like video streams. One specific example, and these examples are always a little bit, I would say, difficult to handle for companies, of course, because there is a specific gray area that you don't want to get into in terms of privacy and in terms of what are we able to monitor and what not. So that's always a very difficult debate that we do with the customers, and we also challenge them on this. But once you could say that you are using this technology for the good, for the better, and for viable purposes like saving someone's lives or measuring, harnessing the safety of someone on a construction site, for example, that are very valuable use cases. So for a construction company, for example, we've used computer vision to use or to monitor all the camera feeds, all the camera streams that are active on a construction site, and to monitor whether construction workers are wearing their safety equipment, yes or no. And this could be like a hard hat, but it could also be like safety goggles or safety shoes and these type of things, depending on the area on the construction site where they are located at a specific point in time. Could also be that one specific area on a construction site or in a manufacturing building is not accessible. So you're not allowed to access that because something is in motion, there's a machine working and you're not allowed to enter. But then we can monitor, this is what's called object detection. Basically, we can monitor if there is a person visible on the image, which is a potential hazard, of course, because it could delay your production process if you need to have a shutdown, for example, for safety reasons. But you also, of course, want to avoid any injuries, incidents, and accidents for the workforce, not only for the workforce, not only for the employee and for the sake of the employee, but also for the sake of the company, because we all know that the cost of an accident, the cost of injuries within your workforce is significant, I would say, in terms of hidden costs as well. So someone is not only able not to work for a specific point in time, but then you also have difficult conversations to do with with unions, with insurance companies, and all this type of thing. So you just want to avoid it. And for this, we have a solution that is continuously monitoring suspicious or dangerous behavior, people not wearing their safety equipment, or people being present on locations where they shouldn't be present, for example. Another project that we're currently working on in the COVID area, I would say, is on contactless access control, which is also based on computer vision. So in the past, we're doing this for one specific production plant in the south of Belgium, in the Walloon region, for those who are familiar with the different parts of Belgium. But there's a glass manufacturing company, and they had an access control system that was using fingerprints. So basically every employee, they have about 400 at that specific site, was obliged to put his finger on the same piece of glass as the previous one did 2 minutes ago. And this in COVID times, where of course you don't want to touch all these surfaces, like everyone wants to touch all these surfaces. And this was of course quite a potential risk for the company to have a local outbreak of this virus. Once it would be somewhere among their workforce, it could be become quite quickly a potential outbreak in the entire company, which is something you don't want for your employees, again, but also not for your company, because again, you have capacity problems. What we did is we built a computer vision based access control system that is using cameras at the entrance of the factory to scan people that are entering the building. And we are going to check, do we know this person? Is it indeed, for example, Niels? Okay, we know Niels. Niels is an employee of the company. Niels is allowed to enter. But then we also connected it to a planning system. So, okay, we know Niels. Niels is an employee of the company, but is he scheduled? Should he be here today? Is he allowed to be here today, or is he here unannounced, for example? And then we will still deny access if you're not announced for contact tracing and for social distance purposes. And then the third step, of course, obvious one as well, is fever screening. So we use thermal imaging as well to check whether the one that is entering, if he is scheduled, does he have a fever, yes or no? If not, again, access will be denied. If there's no fever detected, then he will be able to access the plant, which is also a computer vision use case where we use it for the good, or we use it for health and safety purposes, to monitor and to harness the safety and the well-being of employees on sites. One last example that we did for the Vinci Group in France, which was a proof of concept for the French railway stations, was monitoring of dangerous and suspicious behavior. And this is one of the use cases where you could start to argue, is this going towards the gray area or not? So what we did there is we monitored all the video feeds of the cameras that are present in the railway stations, and we monitored it for dangerous or suspicious behavior, being someone that is running. If someone is running, well, then again, in a railway station, it typically can happen that you're late for your train and you need to run, but we flag it as being suspicious. But of course, someone who is wearing a weapon is suspicious unless this person has a police uniform. Then it's not suspicious. But if he's wearing a weapon and he doesn't have any uniform, then it's suspicious. If someone is taking like really bold moves, he is running and he's stopping and looking left, right, really nervous behavior, again, suspicious. Someone falling on the ground could also be dangerous, because this could be a medical urgency, and all these type of use cases. Again, it's basically for protecting the people, it's for harnessing the safety, but then again, this is some use case that you could argue that is going towards a Big Brother type of scenario. Of course, we as an AI and a data company, we disagree, but the public opinion typically treats these use cases as a bit more sensitive and a bit more delicate to work on.
Yeah, it's definitely been a bit of a hot potato topic in terms of how invasive potentially these types of approaches could be as as citizens' rights, going on public transport and just being present in public places. But as long as, as you say, as long as the objective is clear, it's designed for the safety of citizens. It's designed to help protect us. It's designed to help us. In like you say, when someone's has fallen down, they may be injured, they need help from the emergency services, and those calls can be made to those services pretty much instantaneously, right, with some very quick decision making. So I think this is kind of where where the smart cities of this world are heading to in terms of the direction. It's now all about how can we use technology to improve the quality of life for our citizens. How can we make these cities the safest in the world, right? And how can that impact can be felt, on a day-to-day basis without becoming the big brother, as you say, because let's face it, none of us want that. But when we need help, we want help. When we want protection, we want protection, right? So what was just to give a flavor, Vladimir or Niels, on kind of what was the kind of size of the data sets that you guys were working with, to achieve some of these use cases?
Maybe just as a quick mentioning, we're going to use my mic because apparently the mic of Vladimir had some trouble. It's still unclear or too loud or not loud enough. Just interrupt and let us know, okay?
Sure.
Yes, indeed. So the size of the data set depends on the complexity of the task. So indeed here, for instance, for detecting a helmet, a yellow helmet or an orange helmet, you don't need a large data set. You can do it with hundreds of images. But for harder tasks, for instance, where lots of context is important, for instance, for the security case that Niels has mentioned, there indeed more larger data sets might be necessary, where I'm talking about thousands of images, maybe even thousands of thousands of images.
Gotcha. So it's not. So the potential is there is not to have, we're not talking about even terabytes or petabytes of data, but these models can be trained on much smaller sets.
Yeah, and I think. Sorry. I was interrupting.
Sorry, there are two, just to make it clear about the privacy piece as well, these are all about perimeter detection, detecting people and whether they need to be wearing items or not. It's not about individual faces as such, it's perimeter detection and zones, which people may think that they're recognizing the individual people, like in this picture now, they're looking at what might be individual faces and whatnot, but it's not about that, it's about making sure people are in the right places that need to be, right? Is that kind of it?
Yeah, exactly. Of course, except for the case that we did for access control, there we need to identify someone. But for the biggest part of the projects that we do, we don't need to identify someone as a person. We just need to identify dangerous behavior or or I would say a dangerous situation, and then we can act upon it. But we don't need to know who was where and when, and that's not of importance for us. And that doesn't really add something to the use case as well, or to the business case in this case. So indeed, it's all anonymous, and you're not identified in these use cases, and we don't even need to. We don't need the information.
Thanks.
And one important thing maybe to mention in terms of data, the question that you had, Taylor, a lot of pre-trained models exist on the market today as well. So like, for example, algorithms to detect persons, that's someone that someone somewhere has already built multiple times. So you don't need to build new models from scratch for every different type of task. You can use open source or technology that is available on the market today that already have pre-trained person detection or helmet detection or bus detection, train detection. So not for everything, but for a lot of these objects that already exist, and you can quite easily start integrating, and you can retrain, of course, but you don't need to start training from scratch.
Yeah, absolutely, and that's the brilliant thing about the industry here now is that there's a lot of focus on this space, right? There's a lot of groundwork that's been laid for these types of models, right? For these types of use cases that we can all benefit from not having to start from scratch, right? Mm-hmm. And we can get a head start here, and it's which will massively impact the kind of the time to actual real tangible results when you start training your models, because you're not starting from kind of completely uncharted territory. Mm-hmm. So now just kind of changing gears a little bit, going into kind of one of my favorite use cases, I think is now all around kind of smart wearables and sensors, and being a keen Strava user, myself and cyclist. I was very intrigued when I saw this, how data was being used from an application like Strava. Obviously, everybody who's potentially cycles or runs on a regular basis will know what Strava is. It's an application, obviously, on your phone that kind of records all your physical activity, or in my case, the lack thereof. So is a great reminder to me to actually get out the door and get exercising. But this particular use case is really good in terms of it's combining a really cool sport, of which I wish I could do. I wish I could surf. Couldn't surf to save my life. But also combining surfing and predictive analytics. I mean, how did we get there?
Indeed. So here it's a very interesting case, and I think once again it sort of links back to the previous point where we can combine both a bottom-up approach by starting to leverage really fine-grained data, like here, for instance, the data from individual runs or individual surfing sessions, to get really high-level, large-scale insights. For instance, here the goal was to monitor erosion patterns and beach loss in South California in the United States. So the idea here was to use the data from individual wearable devices, for instance, smartwatches or other devices that the surfers use, to try to estimate the level or the beach level or the water level in various beaches. And the challenge here at the moment the project started was that information was really coarse-grained. So let's say the state of California had really very coarse-grained data for the coast erosion, for where the beaches are. And the idea here was to use very fine-grained GPS data from the smartwatches to see where the people are running, because apparently when people are running on the beaches, they really hug the waterline because that's where the soil is the best for jogging. And also to use the data from surfers who surf very close to the beach, of course, to build a very precise picture of where the shoreline is at any moment in time, depending on the tide levels, depending on the season, depending on the weather, and so on. And to use this to monitor erosion and to give information, to give data to the policymakers to make the right decisions as to land management and real estate management, and so on. And another example, a bit more, how to say, personalized and local, is examples of Six Wolves. Is another client of ours who are trying to reinvent physical therapy by using the wearable technology to automatically monitor the progress in certain exercises. And here, once again, so the idea is to really zero in on the particular context of a particular exercise of a particular person, and to use very fine-grained data to give feedback to the people who are making exercises, for instance, push-ups or squats, and so on. And this is really necessary because doing the exercise for rehabilitation is really hard on your own without supervision, because you don't know where your bones are in relation to each other, where your joints are in relation to each other. And here we can use the wearables, the smartwatch and the bracelets, to really get a fine-grained idea of the fine-grained model of a movement, and use the data from multiple people and the expert knowledge from the physical therapist to give feedback. Are you moving correctly, and are your exercises actually helping you to recover from your injury or otherwise?
Yeah, absolutely. I think that's the promise that wearables are giving us today. That that all that data that's being transmitted or being generated around our exercise, our movements, right, can then be analyzed, right, and then can then be conclusions and decisions can be made, and predictions can be then made around our physical condition, and the physical therapy. It's a great example. I mean, people spend a lot of time after being injured, going through, very long sessions of physical therapy, trying to get back to that optimum state. And the fact that, now our wearables can help, potentially fast track that, is pretty cool. Which I think it really kind of leads really well into one particular interesting use case around kind of the elderly, right? And people that later on in life are becoming potentially more unstable and are more prone to fall, to falling and accidents and things like that. And I know we're all at some stage going to have elderly parents to look after. So anything technology wise that we can deploy and leverage to ensure their safety is going to be really welcomed. And I think Apple brought out a feature when they brought one of their watches around, trying to detect when people fall, right, and have issues. But this looked like a very interesting, shall we say, project that you guys worked on here. And just kind of curious, where did the name come from? Where did Jane come from?
Well, actually, I have no idea, because it's a company, of course, that we work for, and it used to call they used to call themselves Charlin, but then they changed names. And Jane, I think, if I remember correctly, that it was one of the founders of the company whose grandmother was named Jane, and that was the origin. But I'm not 100% sure where the name actually came from. But maybe, Vladimir, you can go a bit more detail into what we've did and what the solution looks like today.
Yeah, indeed. So Jane is a software hardware system, in fact. So it's not based on the wearable sensors, but rather on the motion sensors that are installed in a person's home at the strategically selected locations that just daily measure the activity, the motion in every room of a person's house. And on a software level, we observe and we learn with using machine learning algorithms typical behavior patterns of this person. So in particular, you can see here the illustration. So you see where typically activity happens throughout the days, in which rooms, right? So for instance, you see that at night, it mostly happens in the bedroom, and during the day, it's mostly in the living room and in the kitchen. And then you can really, by observing the person for a few days, you can learn very specific, very precise behavioral patterns. And once you notice the deviation from this pattern, so for instance, here you can see that some activity is expected in the living room, but there is none at this moment. The system can use this observation of a certain anomaly behavior to trigger an alert that will be sent to the relatives of the person and to the medical personnel, to a nurse that is responsible for this person. And indeed, so this system really enables to improve the quality of life and to increase the time that the people can stay in their own home, the home they're used to, where they're comfortable in. And it's really, I think, a nice example where you can use technological advances to improve the quality of life for everybody, not only for highly digital people, but also for the elderly.
Yeah, absolutely. And I think every single one of us knows that independence, has a lot to do with, shall we say, the older generation's mental health. When that moment comes when you realize that you need help, and potentially 24/7 help, that has an impact, right, on kind of your mental state, mental health. And the fact that this is a great use case of how we can help that generation stay in their homes longer, maintain that independence longer. And yeah, and it's obviously you guys are using kind of motion sensors, right? Potentially can then be combined. That data can be combined with, again, the wearables and the sensors, you know, down the road, right, to even increase its accuracy.
Mm-hmm.
So yeah, it's a fantastic use, and a great high impact on society and various you know, generations, you know, that will appreciate, you know, these types of innovations using kind of AI and ML. So I'm just conscious of time, and I want to take some questions. So perhaps we had a couple more use cases, but as always with very interesting topics like this, it's you know, easily to get carried away. We could be here probably for a few more hours talking
Definitely
through it. But I think if we jump to the end here, you know, that would be great, because I think we both agree that you know, AI, ML, you know, it's a journey, right? And
definitely, yeah.
I think we demonstrated today, just in a, you know, short 55 minutes here, that possibilities pretty much endless, you know, and what you could potentially discover along the way. Because I think you mentioned in the one use case where you started out with one project, and as a result of that project, it spun out a completely brand new initiative out of that one project. But I'm gonna shut up now and go to actually see what questions that we have, and see where we go from there.
Okay, guys, so this is one that came through right at the start, saying, are there any hardware devices or special sensors involved in gathering data?
I think if I would answer this, Taylor, I don't know if you were about to answer it, but I think it really depends on the use case. We have a lot of use cases for which we don't need additional hardware. For example, we've done a use case as well, which we didn't mention, but on profiling driver behavior. And one could say, like, okay, we need additional sensors to monitor the acceleration and the gyroscope, etc., to monitor how cars behave. But basically, we don't need it because we all have a smartphone, and a smartphone already has a lot of sensors in there, and they generate a lot of sensor data continuously. So for some use cases, yes, we will need additional trackers, additional sensors to monitor specific conditions. For others we don't, then there might already be sensors in place, also in production environments, for example. And then, of course, another important one that's a condition that we need to check, depending on the use case again, is also the frequency through which we get data. For some use cases in production environment, it's important that we have a high frequency in the data that we have, like every half a second, every millisecond, or every second, or every 15 seconds. It really depends on how frequent we get data from a sensor, whether it's sufficient to build a specific use case upon. So it's really difficult to generalize to say, like, yes or no, we need specific sensors.
I think in the Bridgestone use case, you guys actually fitted the car with a specific sensor.
Yeah.
So that's a great example of that, right? Where it's a specific sensor.
Well, yes and no. In the Bridgestone case, we didn't really fit it with a sensor, but we used a dongle that captured all the sensors that are already in the car, because the car already has hundreds of sensors. Yeah. And we used a dongle to collect this and to send it to a connected car platform. Because the biggest problem, but this would bring us too far, but the biggest problem that the automotive market has today is that every brand is trying to protect its own data. And no one is building a connected car like BMW is not going to share its data with Audi or with Mercedes, because they all are building their own connected car platform. So that is the biggest challenge that we have in that specific market. And therefore, we used the dongle to collect it and to send it towards a generic platform. But we didn't really need any additional sensors because they were all in place.
Gotcha.
Okay, next question. On NLP, on the translation of emails, did you translate emails from any of the Belgian languages to English, or were all emails in English? If the former, Belgian to English, can you kindly touch on the type of models you use with regards to machine translation? How were your scores? South Africa have in excess of 10 official languages, some using special characters. Would your NLP approach and tasks work on South African or African languages? If not, what suggestions do you have?
It's quite a broad and quite a long question. What in general, so the use case that we've described, there was no need for translation. So we received emails in different languages. We were able to, or we are able to process like Dutch or the Flemish, French, English and German, also Italian and Spanish. That's the languages that we support from our NLP framework. So our proprietary technology that we've developed, our algorithms support these languages. But of course, there's a lot of technology already available on the market today. And for the languages that we do not support ourselves as is, we use, for example, Microsoft technology or Google technology or Amazon technology or any type of technology. Could also be open source that is available on the market, because it doesn't really make any sense to reinvent the wheel and to try to build everything from scratch again if it already exists. So I would say for these languages, like South African, for example, is a language that we do not support at this point in time, that we would use like open source technology that is available to build a specific use case upon. I don't know if you, Vladimir, want to go into a bit more detail on how machine translation specifically would work, or I don't know if that's also a specific part of the question.
Yeah, well, I would like to first comment, right? It's not always necessary to do machine translation, right? So you can, as Neil said, we can use language, we can build and use language-specific models too, right? So for instance, in Faktion, we built a model that is specific to the Belgian dialect of Dutch, right? So in Belgium, certain part of the population speaks a variant of Dutch that is very close to the standard Dutch, but yet different. And we were able to improve the performance of our models by specializing towards that particular dialect or variation of a language. And then just to comment, maybe to add a new language to a support for a new language to our models, what you typically need nowadays is a large text corpus, right? For instance, so a collection of tasks in that particular language. Very often, for instance, Wikipedia, language-specific Wikipedias are used for this task, right? If there is a large body of digital text available for language, typically you can already start building NLP, natural language processing models based on that. And this could be machine translation models, but also natural language understanding models, sentiment detection models too, and all kinds of models that you can build.
Okay, cool. Thanks very much, guys. I think that was the last question that we've had. I'm sure that if anyone has any pressing questions during close, you can pop them in the Q&A box and we can always come back to you. Thanks very much, everyone, for your time today. I'm going to hand it back to Chris Kitsia, Country Manager for South Africa, to close.